So hello everyone and I welcome you all to our platform that is PW English, and today we are going to start with the most awaited chapter, that is our polynomials, and we are actually going to cover each and everything in this lecture. We are going to cover our some basic of 9th as well, because this is a chapter which you have already done in your 9th. So today we are just going to recap the starting, right, and then we are going to deal with the questions which are going to come in your exams. And adding to that, we will be discussing the deleted portion as well, because I just want to elaborate each and every concept of the chapter to you. So let's begin with the chapter. But wait a second, first of all, tell me, what is the plural of cat? Let's recap our some of the basic singular and plural thing. Tell me, what is actually the plural of cat? Cats, right? Alright. What is the plural of dogs? Dog. But why am I discussing English in our maths lecture? So basically what I want to tell you is that the meaning of this word poly, right? So when we talk about the word poly, like nominals over here means terms, right? And when we talk about poly, that is actually similar to your plural. That means more than one, right? So when we talk about polynomial as a whole chapter, so we are going to discuss about what all are included in the polynomials, right? Poly means many, nomial means term. So an expression which has many terms is known as our polynomials. But ma'am, wait a second, is this the only condition for an expression to be a polynomial? Let us discuss each and everything, and let's begin with our session. So the very first thing which I'm going to tell you is that what are we actually going to discuss in this chapter? So the very first thing we are going to discuss is the zeros of a polynomial, right? The second thing which I'm going to discuss is the relationship between zero and a coefficient. Okay? Like there are multiple relationships. So we are over here going to discuss about the zeros and the coefficient relationship. And the third thing which we are going to discuss is the division algorithm, right? Okay, so the very first thing, ma'am, tell us, what does the word polynomial means technically? So when we talk about, so basically it is a mathematical expression, right, of one or more algebraic terms, each of which consists a constant multiplied and which has one or more variables raised to a non-negative integral power, right? Let me explain this thing in a very much easier way. So what we are going to discuss in our class 9th, we have already discussed about the polynomials in one variable, right, where we simply write down the expression as ax plus b. This is my polynomial, right? And this is one variable. Now what is a variable? Whose values keep on changing, right? That is a variable. So over here the x is a variable, and we have studied basically in a single variable, right? Linear polynomial we can talk about. Now what is this linear polynomial? We are going to discuss that as well. So in simple terms, an expression that consists of your variables, your constants, your degree, that is the power, exponential powers, and your operation comprises your polynomial. Let me show you one more thing. All right. For suppose this is an expression which you can see. You can see that this is 5x square, this is 2y minus 7, right? Now in this expression, you can see some numbers, right? Like 5, like 2, like 7. All right. So basically these are the numbers which you can see. But ma'am, wait, we can also see some alphabets like x and y over here, right? We can also see some power, ma'am. That is power 2, 5x square it is. And we can also see plus and minus. That is it. So basically when all these things come together, they form your polynomial. Now if I talk about here, so basic, this is the 5, this is the x square. Now this is square, so this is your quadratic polynomial, right? And this is a quadratic polynomial in two variables. Why two variables? Because I can see two alphabets in this particular expression. Now if I talk about, this is the exponential power. The numbers which is assigned with your variable forms your coefficient of that particular variable, and this alone number forms your constant, right? So, okay. And these are the plus and minus, which are the operations which we use to actually combine two numbers or two terms, basically, I can say. Now, what are these terms, ma'am? All right. So, the terms are basically the numbers, the whole number, like 5x square, right? Until unless two terms have an expression or an operation between them, they are considered to be single term. Like, I cannot say that 5 is a term. I cannot say that x square is a term. I can say that 5x square is a term, right? So this is one term, this is second term, and this is our alone constant third term, right? Okay, so let's move forward and let's see that some more. Yes, actually polynomial is not that easy. We have to actually focus upon certain specific things, that for an expression, ma'am, does each and every expression forms a polynomial? If I say, ma'am, is x plus 7 a polynomial? If I say that, right? If I say that, ma'am, is x plus 7 a polynomial? I'll say yes, it is a polynomial. But if someone says, ma'am, is 1 by x a polynomial? So I'll say no, not at all. This is not your polynomial. Now the question arises, why? Why, ma'am? If x plus 7 is a polynomial, why not 1 by x is a polynomial? So this is one thing which you have to keep in mind, that for an expression to be a polynomial, the power, the degree, or you can say the exponent of your variable has to be a whole number, right? Okay, ma'am, this is 1 by x. If I take this x to the numerator side, so this will become x to the power negative 1. Is negative 1 my whole number? Is it? No, right? So negative 1 is not my whole number. So that is the reason why this particular expression is not a polynomial. And here, if there is nothing in the power is 1, right? And 1 is a whole number. Now you might say, ma'am, 0 is also a whole number. So any expression, if raised to the power 0, is a polynomial. I'll say, okay, any number raised to the power 0 is equals to what? 1, according to what we have already learned, right? Any variable, any number raised to the power 0 is 1, which we want to come in the class, right? So any number raised to the power 0 is 1. So that is why we take whole numbers and not natural numbers, because 1 or any constant number, or you can say even 0, is a polynomial, right? I will say that single 1 is also a polynomial. Why? Because there is no expression, there is no variable, right? Okay, so let me say, I can write 1 as 1 into 1. I can write my 1 as 1 into 1, right? I can write this 1 as 1 into x to the power 0, because I know that any number raised to the power 0 is 1. So I can write this 1 as x to the power 0. Very easy, right? And this will be by polynomial again. And if I talk about degree, that we are going to discuss now. What is degree? College degree? No. We are going to discuss what is degree as well. I think you have already learned that thing in our class 9. But let me repeat that for you. Okay, so let us stick to the note. So for any algebraic expression to be a polynomial, for any algebraic expression to be a polynomial, the very first thing which we have to keep in mind is that the exponents of the variable should always be a whole number. Very important question. And the question comes from this concept as well, that tell us whether this is a polynomial or not, right? So how are actually we supposed to find that out? Just by looking at the degree or the exponential power, that it has to be a whole number. Sorted till here? Right. Second thing which we have to keep in mind, that there should be no fractional power or variables. Of course, this is just an explanatory part of the very first thing. If we need the power to be a whole number, we have to avoid integers, negative integers. We have to avoid the fractional powers, right? Only and only proper whole numbers. The third part, there should be no variables in the denominator. Why? Just because I have told you the same thing here. Because when I take my denominator power to the numerator, the denominator variable to the numerator, the power becomes negative. So that is why we do not have to take our variables in the denominator. I hope that these three conditions are clear to each and every one of you. Let's move forward and talk about what all we are going to discuss. Okay, so basically there are multiple types of polynomials, right? So first of all, based on the degree is what? The highest exponential power of your polynomial. So based on the degree of the polynomial are considered into many types, but as per our syllabus, we have till cubic. In addition, because your ma'am always provide additional concepts, we are going to tell you about the biquadratic as well. Okay, so if any expression is there in which actually the power is 1, which we have already learnt in 9th class, that particular polynomial is known as your linear polynomial. For suppose x plus 1 is a linear polynomial, right? If I talk about quadratic, any expression in which the highest power of the variable is 2, that particular polynomial is known as the quadratic polynomial, and this is x square plus x plus 3. As simple as that, the power, the degree has to be 2, the highest degree. If I talk about the cubic, yes, you are right, the power has to be 3. Alright, as simple as that. So x cube plus 2 is your cubic polynomial. It is not mandatory that in a cubic polynomial you need to have a quadratic as well, a linear as well. No, x cube plus 2, that is cubic, plus simple a constant will also give you a cubic polynomial. And when we talk about biquadratic, and we also call it quartic, right? So these are the two names which are given for a polynomial if the degree of the polynomial is 4. Right? So if the power is 4, so we call that particular expression as a biquadratic polynomial or a quartic polynomial. So here we can write as an example, that is x to the power 4 plus x square plus 2. This will simply form my biquadratic or quartic expression of polynomial. I hope that based on the types of power, you are clear with the linear, the quadratic, the cubic, and the biquadratic and quartic polynomial. Now let's move forward and see that our degree name and example. So this table is actually helpful for you people a lot, because this will help you to recap the chapter by the end of the basically session, and in fact in the starting of your exam. Alright, so basically what is a zero polynomial? The simple expression 0 is considered as a zero polynomial. Its degree is not defined, that's why it is specifically known as zero polynomial. And here the example is 0, right? For a constant polynomial, for an expression where we do not have any variable, we are only having a constant, right? I repeat, for an expression where we do not have any variable, we are only left with a constant number. That particular thing is known as a constant polynomial. For example, 1, 7, 8, 23, any number, any constant which is only present over there without any variable. The next thing is linear, quadratic, cubic, quartic and biquadratic, which we have already discussed. So basically you can keep this with you, right? And you can have the PDF as well, because this will actually help you to recap the chapter. The next thing which we have is based on the number of terms. So okay, if we talk about the number of terms, I have already told you what are terms. So basically a coefficient, a variable, a exponent and even a constant number forms your term if they are bounded by two other operations, right? So if I say monomial, binomial and trinomial, what does that mean? For an expression, if there is only one term present, so we call that particular expression as a monomial. Alright, so monomial, basically any expression in which only one term is there, and that one term can be anything. It can be a constant, it can be a variable itself, without coefficient, without power. It's a monomial, right? If I talk about binomial, any particular expression with two terms in it, I repeat, it is only and only based on the number of terms, not I guess you are getting confused by linear and monomial. So let me just write this as x square. X square is also a monomial. Why? Because it is again one single term. We are not judging it on the base of a power or any other thing. If we have only one single basically term in that particular expression, so that is known as your monomial. If we have two terms in a particular expression, that is your binomial. And here we can say that x cube plus 2 is a binomial. Why? Because we have one term and two terms in this particular expression, so it is a binomial. And trinomial, again easy peasy lemon squeezy. Why? Because it consists of your three terms, and those three terms can be any terms. They just have to be combined together with different operations. So based on the number of terms, we have monomial, binomial and trinomial. You might get question that tell which one of the following is a monomial, binomial and trinomial, and I know that now you can do it very easily. Okay, let's move forward now. Based on the number of variables, right? This is something which is new to you. This is something which you should know. All right, you might get to see in your paper as well. So basically, depending on the number of variables, as per this chapter for you is in single variable, so you do not have to worry for that. But again, for some extra knowledge, let us get that. So based on the number of variables, the expressions can be categorized as univariate, bivariate and trivariate. Uni means 1, bi means 2, tri means 3. Right? So number of variables 1, 2, 3. Examples are also given: x plus 9 because only x is the variable. Second example, x plus y plus 9 because there are two variables, x and y. And third, x plus y plus z plus 9. There are three variables, that is x, y and z. So depending on the number of basically variables present in your expression, so we can categorize the particular expression as uni, bi and trivariate. I hope this is clear too. Now let's move forward to 0 of a polynomial. Ma'am, first of all tell me, is 0 of a polynomial and a 0 polynomial different? Yes, they are. So basically 0 polynomial, if I talk about, it is only one 0 present over there. But 0 of a polynomial tells me about that value of your variable which I put in that expression, and that expression comes out to be 0. For example, if I have x minus 6, alright, and I ask you that what should I keep at the place of x so that this particular expression becomes equal to 0, right? You will say, ma'am, take this minus 6 over there with 0 and you are left with x equals to 6, right? Now this x equals to 6, if I put this in this equation, so this will give me 6 minus 6 which is equals to 0. So my left hand side and my right hand side are satisfied. So this is only the 0 of a polynomial. So basically a real number alpha is called the 0 of a polynomial if p at x, right, of p at x, if p at alpha is equals to 0. That means if I substitute the variables of the expression with that particular number, so my expression, my whole expression becomes equals to big 0, right? So this is what a 0 of a polynomial known as. And let us move forward. What is the relationship between 0 and a polynomial, right? 0 of a polynomial and its coefficient. Alright, let me take the very basic quadratic polynomial which we guys talk about, that is ax square plus bx plus c. Alright, this is a polynomial, right? A quadratic polynomial because the power of x is 2 and there are 3 terms, so it is a trinomial. Okay, and let me talk about that a is the coefficient of x square, the number which is assigned to x square. B is the coefficient of x and c is the constant term over here. Alright, so what is the relation, right? We have already learned about the middle term splitting in our 8th classes, right? We know that if we have a quadratic equation, if we have a quadratic polynomial in fact, so we can split its term, the middle term, and get 2 of its zeros. 2 of its 0 means basically 2 particular those numbers which we when put in the equation or the expression, so the expression turns out to be 0, right? And I know that if I have the power 2, if my expression has a power of 2, that means that I can have at most 2 zeros. Why did I actually use the word at most over here? I'll tell you. Like for a quadratic polynomial or an equation, the maximum zeros which you can have is 2. But the minimum zeros you can have is 0. And you can also have 1, 0. How? Let me tell you with a graphical representation after this concept, but let me first explain you the relationship between the 0 and the coefficients. So let me say that when I did middle term splitting to this particular expression, I got two zeros, that is alpha and beta. Alright, let me say that alpha and beta are the two zeros of this particular expression. And also, if alpha and beta are the two zeros of this particular expression, so I will get the factors like x is equals to alpha and x is equals to beta. If x equals to alpha and x equals to beta are the zeros of this particular expression, so x minus alpha and x minus beta will be the two factors for this particular equation, right? With the middle term splitting, just reverse the step. At the end, you get x equals to this and x equals to this, but above that step, you have x minus plus something and x minus plus something, which you equate to 0 and you get two factors like this. Alright, so before telling you the relationship, I would like to prove it for you people, right? That actually from where does that relationship came forward? So if I say that alpha and beta are two zeros, so x minus alpha and x minus beta becomes the two factors. If I equate this equation, which is our basic equation, that is ax square plus bx plus c, with these particular factors, that is x minus alpha and x minus beta. Alright, with a constant over here. Now why this constant? Because I did not know and I do not know that what actually we took in common before solving, right? So for a safer side, I took this k, which will anyhow get, substituted, so don't worry about that. So if I solve this particular expression, so this will give me the the left hand side will remain as it is, that is ax square plus bx plus c equals to and if I multiply each and everything from this bracket, so what I will be getting, so we will be left with k x square. Like first of all, we'll multiply these brackets, right? So I will be getting what? I will be getting my kx square over here minus k alpha plus beta into x, because alpha plus beta I have taken common, x is again the thing, and k is the constant which will get multiplied to each and every term out there, right? So k alpha plus beta x, and then I will be left with k alpha beta. So this is something which I got when I multiplied this side of the equation, right? So basically now what we will do, we will compare the coefficients of here with the coefficient of this side, right hand side, because these equations are equal. So what I'll do, so my a is equals to k as per the question, my a is equal to my k, right? As per the question, my b will be equals to my k alpha beta, and as per the question, my c will be equals to k alpha beta. So we are going to do nothing, just equate each and everything. So my a is equals to k, my b is equals to k alpha plus beta, and my c is equals to k alpha into beta, right? So these are the three things which I have now. Now what I will be doing, I will simply replace the value of k, that is a, in b and c. So if I take my equation b bacha, so what is left with me? So basically b is equals to, I will replace this k with a, right? This is a alpha plus beta, all right, minus over here and minus over here, all right, and this c over here I have is a alpha into beta, all right. So this minus has to be taken care of along with b itself, and here also, all right. So when I take this over here, my minus a with the b, so I am left with b by minus a, which can be written as minus b by a is equals to alpha plus beta, as simple as that. And here I am left with c by a, which is equals to alpha into beta. So from here comes the relationship between the zeros and the coefficients of a particular polynomial. So what we got over here is when I add, basically alpha and beta were the two zeros of the particular polynomial, right? When I add these two basically zeros, so those are equal to my minus b by a. Now what is this b? This b is the coefficient of x from your particular polynomial, and this a is your coefficient of x square from the same particular polynomial. Now if I come back to the product of zeros over here, so what I am left with? That is equals to c by a, and c as per the polynomial is your constant expression, right? And then we have a, again the coefficient of your x square. So with here we derive the relationship between the zeros and the coefficient, that if I add both the zeros of a polynomial, that is alpha and beta, those are minus b by a. And if I give the product of the two zeros, that is alpha into beta, that is equals to your c by a. I hope this thing is clear. And let's see. Okay, so this is just a summary for the same thing, that product of zeros is c by a, sum of zeros is minus b by a. And sometimes we get a question that if product and sum is given to us in the question, we have to actually find out the polynomial. We have to derive the polynomial. So in one single step we can do how? That x square minus alpha plus beta x plus alpha beta will give you what? Your desired polynomial. That we will be doing a question with this particular concept as well. So let's move forward, and here we go. Graphical representation of your zeros of polynomial. Alright. So as far we have already learnt in our 9th class that a linear polynomial always gives a straight line, right? If we plot a linear polynomial on a particular graph, that always gives us a straight line. But ma'am, tell us, what about a quadratic polynomial? So whenever we plot a graph of a quadratic polynomial, it always gives us this U-type shape, which is known as your parabola, right? And this U-type shape can be upward as well, can be downward as well, depending on the a. And what is a? That is your coefficient of x square. If your a is greater than 0, so you will be getting an upward parabola, right? And if your a is less than 0, then you will be getting a downward parabola. So depending on the power of a, right, depending on the value of a actually, so you will be getting your parabolas. Now if I see in this particular equation, just recap one thing, how we actually used to solve the linear equations. The linear, if we have to find out the solution, if we have to plot a graph, so basically what we used to do, we used to take out 2 to 3 points and plot them on the graph, then draw a straight line and check whether our graph is right or not. But how about the quadratic polynomial? Same thing, right? What we do, we take our expression as y equals to maybe x square minus x plus 6 or something, right? We put some value of x square and we get the value of our desired y. That's why when we plot the graph, the zeros which are there are always considered the one which are intersected on the x-axis, right? We do not see the zeros on the y-axis. I repeat, we always see the zeros on the x-axis just because we take our points on that particular thing. So I can see that I know that a particular quadratic polynomial can have at most 2 zeros, not more than 2, but yes, less than 2 is possible, right? That's why the word at most was used. Okay, so when we talk about this particular graph, so you can see 2 points a and a dash. So basically this parabola is cutting this x-axis at 2 different points. So for whatever equation or whatever polynomial I have drawn this graph for, will always have 2 different zeros of your particular polynomial. So for suppose, let me consider that this particular point is 1, 0 and this particular point is 1, 0 for your given polynomial. Next thing if we talk about, okay, so this is a case 2, that when our parabola, ma'am, you said that a quadratic polynomial will have 2 zeros, but here the parabola is actually cutting the x-axis at one single point. So we have seen in many equations and polynomials what? That we actually sometimes get both the values of x same. Like x equals to 2, x equals to 2. We get both the values of x same. So basically this means that two zeros are there for your quadratic polynomial, but both the zeros are same. Ditto, copy, paste, right? So both the zeros are same, but of course the value is same, but we have that at two places. Now at case 3, when we see, okay, first of all tell me that this is an upward parabola, right? So we can see from the graph that if this is an upward parabola, so your value of a would be greater than 0. This is what we can say about the equation or the polynomial. Okay, next, it's in the air. Ma'am, it's in the air. The parabola is in the air, right? So it is not touching your x-axis at any single point, right? So this particular expression will have no zeros. That's why I use the word at most when I was talking about the number of zeros, because it can at most have two zeros. It can also have 1 0, and it can also have no zeros. I hope this thing is clear with everyone. Let's move forward. Okay, so the question says, find the zeros of the polynomial 2x square. Okay, let me write down the expression. That is 2x square plus 5x minus 12, and verify the relationship between its 0 and coefficient. First of all, we have to find out the zeros, right? As per we know the middle term splitting. So how? What will be basically two numbers which we basically add and subtract will give me 5, and if I multiply those two numbers, that will give me what? 24, 8 and 3, right? Yes, let me write it down. So I will be getting 2x square plus 8x minus 3x minus 12, right? I will be taking common. So from these two numbers, I can take 2x common, and I will be left with x plus 4. From here, I can take 3 as common, and I want plus sign inside, so I'll take minus outside, x plus 4. Now I will take this x plus 4 common because it is repeating in both the sides. So x plus 4 common, and then I am left with 2x minus 3 in one bracket. So I will be finding out the value of x. From here I will get the value as minus 4, and from here I will get the value as 3 by 2. So basically these are the two zeros of your polynomial. I can name this as alpha, and I can name this as beta. Alright, clear till here? Nothing new. Middle term splitting, find out the value of x, that is it. Okay, so what next we are going to do? We have to verify the relationship as well. That was our alpha plus beta and alpha into beta, right? So first of all, sum of zeros, right? Sum of zeros was given by minus b by a. Simple. Alpha, what is your alpha? Minus 4 plus what is your beta? 3 by 2, right? I'll take the LCM, so I will be getting minus 8 plus 3, that will give me minus 5 by 2. This is my alpha plus beta. Now if I find out the same thing with my minus b by a, so what is b over here? 5, and what is a over here? 2. But my expression has minus in itself, so minus 5 by 2. So these two terms are equal now. So hence the relationship is verified. As simple as that. But now if I have to take out the product of zeros, right? This is for the sum of zeros. This was for the sum verification. And now if I have to take out the product verification, right? Okay. So product of zeros, that is alpha into beta. As simple as that, right? Alpha over here is my minus 4. Come on, do it with me. I want you guys doing it with me right now, right here. Okay. So minus 4 is it. And then we have 3 by 2. Multiply by 3 by 2. 2 and 4 will get cancelled out by 2. 3 into minus 2 will give you minus 6. And similarly, if I check it with the equation, right? So we have 2x square plus 5x minus 12. What was the product of zeros? Which was equals to c by a. What is our c? Constant term over here. Minus 12. What is our a? 2. This will get cancelled out, and this will also give me minus 6. So hence we have verified the relationship between your zeros and the coefficient. I hope this is done, clear, easy peasy, everything for you people, right? Okay, let's move forward and see what's in the plate for us. So find a quadratic polynomial. The second step which I told you, that in a single step, how can you actually find out a quadratic polynomial? Up here the sum and product zeros is given. I'll tell you one exception for this question. Listen to me very, very, very carefully. I want your attention. 3, 2, 1. Good. Okay. So in some questions, you are given with the sum and the product itself, right? You are given with the alpha and alpha plus beta and alpha into beta in this particular question. But sometimes when you practice such questions, you always think that in the question itself, in the paper itself, it is always given the sum and the product, but that is not true. In certain cases, and I guess last year, somewhere's paper, I have seen that they intentionally gave you alpha and beta. Instead of the sum and product, they have given you alpha and beta, right? But the students start solving it as per the sum and product is given and they got 0. So what you have to do, you have to actually read the question very, very carefully, bacha. Just because, why? Because certain times the examiner tries to trick you. This is something which you can see in NCERT, right? But that is something which was different, that we are not given with alpha plus beta, we are given with alpha and beta separately. So in that particular question, what we have to do, we have to find out alpha plus beta separately, alpha into beta separately, then we have to include that in the particular format of the expression given. But यहाँ पे we have sum alpha plus beta equals to -5 is already given to you. Alpha into beta, that is equals to 6. This is also already given to you. So when sum and product is actually given to you anyhow, so how is the expression formed? Simple x square. The first of all, we have x square. We have minus alpha plus beta into x, right? And then in addition, we have alpha into beta. Now we just have to substitute the values. So we will be left with x square minus alpha plus beta is -5 into x plus alpha and beta is your 6, which is already given to you. So now this minus will turn into plus and we will be having the polynomial x square plus 5x plus 6. Simple, dimple, right? Okay, let's move forward to the next thing. Okay, so this is your CBSE already asked question. If the product of the zeros of the polynomial ax square minus 6x minus 6 is 4, then find the value of a. Simple question, just a bit of brains. If the product is given, I know that product of zeros is alpha into beta. Simply write it down. Alpha into beta is given to you as 4 and we already know that. Why? Because we are very, very smart, that alpha into beta is also equals to your c by a, right? Alpha into beta is also equals to your c by a. So here c will be equal to the constant term, that is -6 bacha, and a is equal to the, right, coefficient of your x square, that is simply a. Right? We know that c by a is equals to product of 0. We will substitute the value directly. That is 4 is equals to -6 by a. And from here, I can say that my a is equals to -6 by 4 and my a is equals to -3 by. As simple as that. Tell me, is this thing clear with everyone? Easy peasy. Right, we just were given with the product, we took out the values of c and a from our given particular equation, and then what we can do, we can find out the value of a from by substituting the values. Great, let's move forward, and here we have another question. If 1 0 of the polynomial a square plus 9x square plus 13x plus 6a is the reciprocal of other, take a deep breath in and listen to me very carefully again. Okay, wherever you see the word reciprocal in polynomial, right, specifically I talk about if the zeros, okay, are the reciprocal of one another, always keep a mark, keep it as a star mark. You have to take the product of 0, nothing else. You do not have to actually move your brain in any other position. You just have to see that if the word reciprocal is given to you, what you have to use, you always have to use the product of the zeros. Simple. But first of all, let us take at least 1 0. What does actually the word this means? Reciprocal. What does this mean? This says if for suppose our alpha is 3, right? If our alpha is 3, that is our first 0 is 3, then the second 0, that is beta, will be the reciprocal of 3. And what is the reciprocal of 3? That is 1 by 3. As simple as that. But here we cannot take any. And we know that always the product of such reciprocals, that is 3 into 1 by 3, will give us what? 1. Even if we take 100, let one 0 be 100, the other 0 will be 1 by 100. The product 100 into 1 by 100 will get cancelled out and give me 1. Even if I take 1 0 as 599, right? Even if I take the reciprocal of 599 gives us 1 by 599, it will get cancelled, and anyhow it is going to give me the product always and always as 1. That is the only specific reason for always taking this product thing when we are solving the questions based on reciprocal part for your polynomial. I hope that this thing is clear with everyone, right? So let's move forward. I have told you that we will use the product, but let me take the first 0 as alpha, right? Let the first 0 equals to alpha. And if I have taken my first 0 as alpha, you can take x or any other thing, but we already have x in the equation. So that's why I have not taken it. So let the first 0 be alpha. So its reciprocal will be, tell me, come on, quickly. The reciprocal will be 1 by alpha, as simple as that, right? If I'll take the product, that is alpha into beta, that are the two zeros basically when we take the product. So this will be equals to alpha into 1 by alpha. Alpha and alpha will get cancelled out, and I will be left with 1 as a product of 0, alright? But I also know that my product of 0, that is alpha into beta, is also equals to c by a, which means alpha into beta is 1, and this 1 is equals to c. Now what is c over here, right? The constant term, and the constant term over here is 6a upon may a. Now what is your a? A is the coefficient of your x square, which is equals to a square plus 9. You have to take this whole, right? Do not forget to take this as a whole. So this is your a square plus 9, right? As simple as that. We'll just cross, we'll take this a square plus 9 with the 1 over there, and I will be left with, okay, so this will give me a square plus 9 equals to 6a. I will bring the 6a to the particular equation, and this will become a square plus 9 minus 6a equals to 0. And if I rearrange this, I will get a square minus 6a plus 9 equals to 0. Isn't this forming my quadratic equation? It is forming, right? So I can actually take my a as x and middle term split the thing and take out my values for the particular a. So what I'll do, I'll take this a square. Minus 6a can be splitted into minus 3 and minus 3a. That will also give me the product of plus 9a. Minus 3a minus 3a plus 9 is equals to 0. Easy till here. We will take the a common from the first two terms. So I will be left with a minus 3. Alright, from here I will take 3 common, and I need a minus 3. I will take minus outside equals to 0. And then I'll take a minus 3 common from here. So I will be left with a minus 3 and a minus 3. So basically both the brackets are going to give me the value as 3 for your a. So this is how we actually calculated the value of a when the particular polynomial was given to us. If we were given that 1 0 is actually the reciprocal of the other 0, right? So this is how we actually have to do. And again tell you this thing, just star mark this, that whenever you see the word reciprocal, especially when we talk about the zeros of the polynomial, always take the product of zeros, nothing else. So please do remember this thing. Don't take the sum, because you will take alpha plus 1 by alpha. That will give you alpha square plus 1 by alpha, and you will be left with nowhere, right? So always take the product of zeros. This is as simple as that. So let's move forward to the next part, that is our cubic polynomial. Alright. So we have already learned about that what are actually cubic polynomials. Any expression which has its power, I repeat, which has its degree as 3 is known as a cubic polynomial. For example, let us take ax cube, simple, plus bx square plus cx plus d. This is my cubic polynomial. Now here certain things change as per the quadratic formula, as per the quadratic polynomial if we talk about. And what are the things? Basically, in that particular expression, we had our b as the coefficient of x. But in cubic polynomial, we have b as the coefficient of x square. So you have to deal with it very, very carefully, because same expression, same variable, somewhere in the quadratic polynomial is telling you about the coefficient of your x, and here it is telling you about the coefficient of the x square. Alright, so here also we have certain tricks and the relationship between the zeros of the polynomial, and how to actually form the cubic polynomial if we have our alpha, beta and gamma. Now what is this gamma? We were just dealing with alpha and beta because those were the things of your quadratic, because we know that at most we can have the number of zeros is 2, right? But in the cubic polynomial if we talk about, so cubic polynomial has your 3 zeros because the power is 3. Now this is one thing which you can keep in mind, that the number of zeros, right, the number of zeros for any particular expression is totally dependent on its power. If the power is 4, it will have at most 4 zeros. If the power is 1, it will have at most 1 zero. If the power is 2, it will have at most 2 zeros. So depending on the power, the degree, you can actually tell by looking that how many zeros are actually possible for any given expression. Now let us see that for a cubic polynomial, the 3 zeros we are taking is alpha, beta and gamma, right? So alpha, beta, gamma are the zeros of this particular expression. Then in this case, we are getting 3 different results. Like as per the case of the quadratic thing, we had 2 results, sum and product. That is it, finish, right? But when we talk about the cubic polynomial, we have 3 different results, that is alpha plus beta plus gamma is equals to minus b by a. Same as alpha plus beta, but we know that here minus b is a different thing, right? A is a different thing. And alpha beta plus beta gamma plus gamma alpha, which is actually known as the product of 2 terms taken at a time, right? And then we have the third, that is alpha into beta into gamma, that is equals to minus d by a. So this is something which is an addition. These 2 things are actually similar, but you have to see as per the question that what is a, what is b, what is c and what is d. Clear? We will be doing questions for the same, so do not worry, we will solve this up. And same as for forming the quadratic polynomial, we had our specific thing, that is x square minus sum of zeros, that is alpha plus beta into x plus alpha into beta. So similarly, when we talk about the cubic polynomial, right, we again have a thing to form the particular expression if we are given the zeros, and that is x cube minus sum of zeros into x square plus the second part, that is 2 products taken together, and minus alpha into beta into gamma, right? So take care of this, please remember this, you might get a question. So let's move forward to the next question and let's see what the question says. So find a cubic polynomial. Again the same thing which we discussed in the last slide, right? So find a cubic polynomial with sum of its zeros, sum of the product of its zeros taken 2 at a time, that means alpha beta plus beta gamma plus gamma alpha, and your product of zeros, that is alpha into beta into gamma, is given to you. Let me write down. First of all, the sum of zeros is given to you, right? Okay. So the sum of zeros, that is alpha plus beta plus gamma, is given to you as 2. Then you have product of 2 zeros taken 1 at a time. So alpha beta plus beta gamma plus gamma alpha is given to you as minus 7. And then you are given specifically the product of 0, that is alpha into beta into gamma, as simple minus 14. Alright, so we have to do nothing, just we have to substitute the values in the previous slide, that is 2, minus 7 and minus 14. Let's see. So here we have x cube. Now we have sum of zeros as 2 according to the previous thing, right? Then we have the product of 2 numbers, 2 zeros basically taken 2 at a time. So we were given this as your minus 7, right? So it is as your minus 7 over here. Simply write down minus 7 x, and then you have minus 14, that was the product of 0, right? Simply just solve the sign. This will be x cube minus 2x square minus 7x minus, right, minus of minus 14. So we will be having plus 14. So this is all about the question, that is x cube minus 2x square minus 7x and minus 14. This minus minus will give you plus over here. So this was just about the cubic polynomial and how you are going to solve this type of question. So let's move forward with the next question. Okay. So the division algorithm of the polynomial. Alright, so when we talk about the division algorithm of any polynomial, what we are left with basically is simple that dividend divisor question and remainder thing which we have already done. Alright, if we talk about fx over here, so fx is the dividend. Alright, if we talk about the qx, gx and rx, so qx and rx are the question and the remainder, right? And when we talk about the gx, it is the divisor of the particular thing. I hope that this thing is clear with everyone. Okay, so what we are going to do, we are going to learn about a long division method which we are going to use for finding the zeros, also for checking if whether a particular divisor is a factor of your particular dividend. So let us straight away move to the question, and the very first question says divide 5x cube minus 13x square plus 21x minus 14 by 3 minus 2x plus x square and check whether it is a factor of the given polynomial or not. Simply, the very first thing what we have to do is to check whether each and everything is given aligned, like either in the ascending or in the descending order. We will be taking it in the descending order because that is convenient to do. So 5x cube, x square, x and constant term. This term is fine, right? But if I have 3 minus 2x plus x square and this is not properly arranged because I need my x square in the very starting, so I will be taking it in the very starting. So I'll rearrange the thing. First of all, let me take the thing, the dividend part, that is your 5x cube minus 13x square. Okay, so we are having 13x square plus 21x minus 14, and the divisor which we have is x square. We will be rearranging that part because we need the x square term in the very starting. So what we are left with, we will be having our x square in the starting, then we will have our minus 2x. Please take care of the sign while doing this. Alright, the minus was with 2x, so we have already taken it with the 2x itself, right? Okay, so now what we have to do, what should I multiply my x square so that I get 5x cube? I should multiply my x square with what number so that I get my 5x cube? With 5x itself, right? So very first thing which I'm going to do, I'm going to multiply this x square with 5x and I will be getting 5x cube over here. Alright, then I will multiply my 5x with minus 2x, so I will get my minus 10x here. And if I multiply my 5x with 13, so I will be getting my plus 15x over here. We have to change the sign. Alright, we have to subtract basically. Signs will be changed. This will get cancelled out. Minus 13 plus 10x will give you minus 3x. And plus 21 minus 15 will give you over here plus 6x, and then we will bring down this minus 14 over here. Now again I have to see my first number, right? Okay, so I have to see my first number, that is minus 3x square. So this minus 3x square, what number should I multiply with x square so that I get minus 3x square? So I will be multiplying my x square with minus 3x. Simple. Minus 3x into x, no, only minus 3, sorry. Okay, so I will be multiplying my x square with minus 3, so I'll get minus 3x square, right? So minus 3 into x square will give me minus 3x square. Minus 3 into minus 2x will give me what? Minus minus plus 6 and x, and then minus 3 into plus 3 will give me what? Minus 9. Again, I'm going to do what? Change the sign because I have to subtract these things. This will get cancelled out, right? Minus 6 and plus 6 will get cancelled out. Minus 14 plus 9 will give me minus 5 as the remainder. So since I am left with the remainder over here, right? So this particular divisor is not a factor, basically I can say, or is not able to divide our particular dividend correctly. So this is how we are going to do that. If we are left with any sort of remainder, that means that is not a proper factor of it. And if we are not left with any sort of remainder, that means that is a particular factor of that particular expression which is given to you. I hope that this thing is clear with everyone. So let's move forward and see our next question. Okay. So an important note which I have already told you about, that if alpha is a 0 of a polynomial, then x minus alpha is a factor of that polynomial. If we have alpha, for suppose if 3 is a 0 of any particular expression, right? If 3 is a 0 of any particular expression which we talk about, so after that, if I'm saying that x equals to 3 is a 0, so that means x minus 3 is a factor of a given polynomial. Also, if I say x equals to minus 2 is a 0 of a given expression, so I can say that x plus 2 will be the factor of a particular expression. So let's move forward with the next question. So what do we have over here? So it is given that 1 is a 0 of the polynomial, that is 7x minus x cube minus 6. Then we have to find out the other zeros. Alright, so this is the same concept which we have studied in the previous slide. That is, if alpha is the 0 of a particular polynomial, so x minus alpha will be the factor of that particular polynomial. Similarly, I know that if 1 is my 0 of the given expression, so x minus 1 will be the factor of the given expression, right? So factor, so we have that is x minus 1, but it's better to rearrange our particular expression so that we are able to divide it in a convenient way. So we will take the x cube term in the very starting, that is minus x cube. Now we do not have any x square term in this particular expression. So what we can do, we can actually add a 0x square from our side, because that will not hamper the equation, right? 0x square, then we have what? Plus 7x, and then we have minus 6. Alright, now let us see that what I have to multiply to my x to get a minus x cube. I have to multiply a minus x square, right? So minus x square into x will give me minus x cube, and minus x square into minus 1 will give me a plus x square. So that's why I have asked you people to write a 0x square, because where would have you written this x square then, right? So now what we have to do, we have to change the sign, that is plus and minus. This will get cancelled out. 0 and minus x square will result in my minus x square plus 7x, I'll carry everything down, and minus 6. As simple as that. Now again, what I have to multiply my x with to get a minus x square? I have to multiply my x with minus x, because minus x into x will give me minus x square, right? Then I have minus x into plus minus 1 will give me plus x, and this is minus x. So again, I will be changing the sign, bacha. This will get cancelled out. Plus 7x minus 7x will minus x will give me 6x, and over here I will be left with minus x into minus 1. That was my plus x, and minus 6 as it is down there, right? Okay, so let's see these two terms. All right, so and this minus 6 will get carried forward. Now what I have to multiply my x with to get a 6 with a plus 6, right? So over here I will be left with 6x, and 6 into minus 1 will give me minus 6 again. I'll change the sign because I have to subtract, and everything will get cancelled out. And if I have my everything cancelled out, so basically this is completely divisible. Now for finding the other two zeros, what we actually have to do now, to find the other two zeros for the particular expression, we have to middle term split the quotient itself. Yes, this quotient itself. So I'll middle term split minus x square minus x plus 6 equals to 0. So basically I have to find out two numbers that are minus 3 and 2x, right? So I will be getting this as minus x square minus 3x plus 2x minus 6. I will be taking minus x common. So I will be left with x plus 3. I will be taking 2 common. So I will be left with x plus 3. So from here it will be minus x plus 2 equals to 0. And from here it will be minus x square minus, we have taken the common, and here we have taken the 2 common, right? Okay. Here it is plus. Okay. Right? So it is x plus 3. Sorry. So x, then we will be taking x plus 3 over here. Now from here we have x is equals to 2. And from here we have x is equals to minus. So basically one of the factor was this itself. That means one of the 0 was 1. Since it is a cubic polynomial, so we have 3 zeros, and those 3 zeros are 1, 2 and minus. Right? So this is how we divide. And if we are already given 1 0, we can take out the factor. Then we have to divide that particular dividend with the factor and take out a question. The remainder will be 0. And with that particular question, we have to middle term split it, take out 2 other zeros, and then 2 zeros we will get, and 1 0 over there already. So we will have the 3 zeros of a cubic polynomial. Right? Okay, so this is one of the homework question for you people. So you have to actually, if alpha and beta are the zeros of the polynomial, this particular polynomial, you have to calculate the value of 1 by alpha plus 1 by beta. So this is something which you have to do for your homework part, and please comment down the answer below. And let me see that who gave the answer, the very first 3 who gave the answers. So I will be surely taking their names in the next session. So I want each and every one of you to comment down the answer for this particular question, and let's see who gives the fastest finger first. And with this we come to the end of our chapter. So thank you so much everyone, and I hope that the session was informative and you loved the session. And I am actually waiting to give more lectures, and the next lecture will be on the next Wednesday. So please keep studying, keep focusing. PWOP, write down in the chat. And thank you so much for your time and love. Take care and have a great day ahead. Thank you so much.